think I will just start. We are Matheus and Eric. Yeah? Here pictures. We are ourselves. We are working as backend developers, DevOps engineers at Link 11. And now we have a talk about some fun parts of programming languages. Yeah? All languages have confusing and unexpected behaviors, which normally are not intended not as intended as the designer didn't want it to have to, but they're not thought out, they're not widely known, or they're just often ignored. And therefore they're fun to talk about. And we found a bunch. And let's start with something easy, the C programming language and arrays in it. What's the output of this? It's correct, it's the same as it is before. And now? Still the same. Why? Oh, it takes a second. Why? Because that's why. Good. And in a bit more words, the C standard from long ago, I think 72 was it, cont. The standard 89, really? Ah, okay. Yes, I know 72 because in the next some of the future slides I have something when they changed something in it, and it was 50 years when it was, but we'll come to it. But thanks. It's a long time still ago, quarter century more or less. Yeah? And in the definition it says that the bracket operator, well, is identical to that, which also means that even the C languages has some kind of syntactic sugar, which for some reason confuses me, because I always thought it was just a primitive language, which is also not right, but well. Yeah. And addition is cumulative, therefore you can just switch the two things around, and this is the reason why, if it loads, this is working. Yeah. I have a bit more an involved example here. This is, in theory, you can use this in production code. Also not this one, because I think this is also faulty because it's not multiplying two matrices, but good enough for an example. Sometimes you have this, and you can, in theory, replace it with this, and it's totally correct, and will annoy your coworkers. The coworkers will have that in your mind, and if they have that in your mind, you can also do this. Just look at it for a few seconds. Good. CSO is the adoption of ASCII. I have to read this because I could not remember this. These things, also the question mark, and then the round, not brackets, braces. The round braces and such, they can be substituted by the things that I have also on my slide. And this is more or less because, well, it predates the divide adoption of ASCII, and not all keyboards at that time in 72 and afterwards don't have these symbols on the keyboard, or they're cumbersome to type. So they just added this. And now it's not really useful anymore, because I'm pretty sure every keyboard or every keyboard layout, and some people have just made keyboards where you can not only switch the keycaps and the key codes on the software side, but also have some small screens on the keycaps, so you can theoretically have anything on your keyboard and type it. Yeah? And also it was removed because you have to now use the command line switches, wrong direction. Called dry graphs and STD. And STD is only there because I found it funny. So, and just for comparison's sake, you see it here. This is got bold. The only difference is you have all three codes that I have here. Can you see the mouse? Yes. This one is multiplying more fun, which should be this one. And this is the normal one. So everything is the same. And here is just that you can see there's just more math that you have to do with the array indices, because I think the standard, whatever is here, isn't smart enough to just put it around and see that, well, yes, you would just want to array and index an array, other way around. Good. I presume no questions or comments? Good. Then something else. Equality in Java. This is true. Easy. And this is correct. Because integer is an object, not a primitive as int. So two different objects, difference. That wrong is true. Ha! Too late. Well, What about that then? This should obviously be false, because it's an integer, a primitive, and the other is an object, so now it's still true. Why? Well, before I tell why, some other parts. This is true. This is, also it's just the other way around. We count up, this is also true. This is something that you can have in production code. String comparisons. What are the three answers? True, false, true. Okay, true is correct, because, well, I think you know it if you say it that way. And the last one is you should know that the equals should use if you can comparison to objects. Why is this so? It compares values and primitives, and the double compares addresses for objects, which isn't kind of true, because an address of an object is just the address in the memory, so it's still some long primitive, but we ignore that. It's easier to explain why. Java holds a cache of frequently used objects. And if you use this thing, it uses the cache, therefore the same object. Oh. There should be more pop-ups here. No. But you can see what I said. If an object comes from the cache, it's the same object with the same address. Therefore, the double comparison works. If it's not from the cache, it's a different object because it's somewhere in the memory that Java has somewhere. So it fails. No? Strange. Just for completeness sake, this is the standard cache that is there. Different versions and implementations handle cache differently. Example, Java has a fixed string cache set, which has many bugs. I worked with Java 7 in university, and this was one of my test questions that I had to answer, and I got it wrong. So now you will get it right. No. And the last part, this is the part where because I wanted to do this, it isn't any true anymore. With the reflection API, you can look at the string cache and also the float cache, byte cache, whatever. And in theory, you could change them. I think they removed this in Java 13. I have to look this up, but I think it was Java 13. So you cannot do fun things anymore, that you just load something from the cache, afterwards change the value in the cache, and then, well, what you compare it against is totally different. You can change true to false and false to true with it. I did this in university, but yeah, it's not possible anymore. And other languages like Python, .NET Runtime also implemented this, also a string cache, byte cache, integer cache. Yeah. Also a byte, 100, I think this has more to do with because Java is based on Objective Oak, which is based on Oak, which... So, couldn't find this out. I just copied it from the official documentation. Maybe they changed it. No, I don't know it. I just wanted to hear for completeness sake. Sorry. No. Yeah, and that's it. There's just some fun things you can do to annoy your coworkers with. Also, you could do, because you cannot do it anymore in Java. No, Matheus?
Yep. Hey everyone. Yeah, we speak a bit about Python, and I will tell a bit about the float pointing. Yeah, for this one, I used the Python version 3.14, and a common example would be this 0.1 plus 0.2 compared to 0.3. Then the expected result should be true, but actually we have this false value. And then I try to understand a bit why is this happening, and then we got that this 0.1 plus 0.2 is this infinite value. Yeah. So something to try to understand, I try to divide some numbers, and then I get the 1 divided by 2 is 0.5, 1 divided by 4 is 0.25, and then I go further a bit, and then try to divide 1 divided by 3, 1 divided by 6, and then I saw that it's infinite numbers. And then when we have infinite numbers, we don't have enough memory to store all these values. Then we have to truncate it at some point. And then when we truncate it, we will have something like that. And then by truncate, we are losing precision. And then when we lose precision, we will have these weird values that is showing up. And then this is a small, but the fun point is that when Python stores, the value, we are storing it in binary, and it's not in the base 10. And then we take a look at in the binary version, we see that we have this infinity numbers again. And then therefore, Python needs to truncate it. And then when we truncate, we are losing precision again. So something to say, this is not something specific to the Python language. It can happen in another language as well, like JavaScript, C, or another language. And here would be how can we deal with that? Python has this built-in class that we can use this decimal class and check, make this comparison. And another one would be this math is close, and then we have this expected value as well. So another topic that I got, it was mutable default arguments in Python. And this is very interesting because if you have this function and we add empty list to the default argument and we append an integer number and print it, we will have here this expected list. But what would happen if we call it again? We will shoot this one. We should get this one. And if I call it again, it will continue to append this number to the list. And why is this happening? This is happening because when we define the function, these arguments are being evaluated at this moment, and not each time it's colored. And then we have this simple, this small problem. So another example that we could use would be add a small function to the default argument, and then we can check it. How is this happening? And then I put here a random choice, green, blue, yellow, to the argument. And then I'm returning it, and I can check that it's always return green. So when I check the magic functions for this, magic methods, then we see that it's green defined already, and this random value is not always being colored. It's colored only once. So when we bring it to a more common function, or production, let's say like that, and then we put this shopping cart class, and we created these items with a default empty list, and then we add some items to this list. We add the potato, the tomato, and then we check what is in the list. Then if you go further, we get this create instantiate another shopping cart, and then we add now the carrot. And then if you call to check the list, what is in this instance, we check that we have a shared list between both instances. And that could bring a lot of problems in production, I can believe. And how could we fix that? To fix that, instead of using mutable, you use immutable items. Then we can use like nonce, and then we define in the constructor the empty list. And then if it's something different from that, we add this to, we cast it we cast it. And yeah, then we get it fixed. Another way that we can do is like use a tuple. Then we have in the same way, but less variables. Then we can fix it in the same way. But I know that could be a lot of ways to fix that. This is just two small examples that I brought. So another thing would be the generators in Python. if we have this simple way to generate a list, then we get this list from 0 to 2, and then we print it. Then what it would happen if I call it again? So we will have an empty list. And why is this happening? Because the generators is not saving anything in memory. He is only a receipt, and this receipt is generate what he knows about this receipt. So I can do another way. I have created this function. It's not a beautiful function, but it's just to explain how the yield works. It's like every time that we call the next value from an iterator, from a generator, we pause the generator, and when we call it again, it will call it until the end, until the end of the next value. Yeah, and the list is calling this next every until the end. So here would be an example of that I just explained it. We get this next, and the next value would be the values that was missing. So then if you call again, it's empty. So generators then knows how to produce the next value on demand and will remember what was the last value yielded. And I would say that to use generator when you don't need all values at once. You don't need all values in memory. So another one, it's the finally. This is not best practice. It's just an example with a simplification to not to do. It's like don't put a finally return in the done and in the finally when you use a try catch exception, and because you can have some unexpected response. For example, if you try to call this method, someone could wait that we have the response charged, but in reality we will get this done because the finally is swallow this return from the try. And after in the Python version 3.14 we have this warning, but in the oldest version we don't have this warning. Then it can happen that you got unexpected behavior if you use return in the finalist. So here is about the documentation from Python 3, and he explained here that the finally close includes a returning statements. The returned value will be the one from the finally close return statement. So that's it. Yeah.
Perfect.
Thank you very much for this amazing talk. We have about a minute or half a minute left for questions. I see a question there.
Java integer example.
Yeah.
It was if you initialize two integer objects. Oh, there's a mic. If you initialize two integer objects with the value 127, they compare equal. But if you do with 128, they don't. What's the reason for this?
In the cache, they are just up to 127. 128 is outside of the cache, so they're no object.
Oh.
That's the reason. This is why I put it in here, because, well, if you don't know this, well, technically this can happen.
Right, so if it's 128, it's initialized ad hoc.
Yeah.
And if it's 127, it's initialized statically.
Yeah.
So
Also Java, and I think the other languages, they have something called autoboxing. But if you have this...
Kotlin.
What?
Kotlin, for instance.
Yeah, Kotlin. Okay, this is more or less working on the Java virtual machine, so I put it in the same category as Java. They have something like autoboxing, where they just more or less interchangeably handle these integer objects, the primitives and the objects associated with the primitives.
Thank you.
Yeah.
Thank you again for an amazing talk, and a big round of applause, please.
Thank you.